Hello, welcome to this lesson in the Chemistry Tutor. We're going to work our last problem with stoichiometry, gas reaction stoichiometry problems here. And so the reaction that we want to discuss for this problem here is going to be the following. Magnesium as a solid plus 2HCl, hydrochloric acid, an aqueous solution, yields magnesium chloride as an aqueous solution plus H2 gas. Now this is a balanced reaction already. You can verify that. One magnesium, two hydrogens, two chlorines, two chlorines. So everything's balanced. Now the question says, how many milligrams of magnesium must react with excess hydrochloric acid, HCl, to produce 28.50 milliliters of hydrogen gas, H2 gas, at 26 degrees Celsius and 758 torr? All right, so first thing you look at is you see you have a solid, aqueous, which means water solution, aqueous, and a gas. So we don't have two gases. There's no way we're going to be using volume ratios in this problem between two gases. We've done problems like that in the past. You understand the point with that. But we are going to have to use PV is equal to nRT here because notice it says how many milligrams of magnesium must react with excess hydrochloric acid. Excess just means you have so much hydrochloric acid that it's not the limiting factor here. You've got a whole bathtub of hydrochloric acid. You want to know how much magnesium needs to react with whatever, a whole bathtub of excess amount of hydrochloric acid to produce a fixed amount, 28.50 milliliters of hydrogen. The hydrogen's given to you in a volume, in terms of milliliters of volume. Okay, but we already know that we can't use volume ratios here. See, that's one way the students a lot of times will go off the rails here, is because this is given to you in terms of liters, 28.50 milliliters actually, and you want to figure out how much magnesium is produced. So if you start using volume ratios like 1 liter of this to 1 liter of magnesium, that makes no sense. You can't measure, well, you can measure a volume of magnesium as a solid, but using the mole ratios as volume ratios, it only works for gases. This is not a gas, so you can't do that. So they're kind of trying to trick you by giving you a volume of H2 gas to begin with. So what you need to start thinking about is, how can I get what I need from what I have? So 28.50 milliliters is the volume of hydrogen gas that I'm given. But I also know that this whole thing's happening at 26 degrees Celsius and 758 torr. So if I know the temperature and I know the pressure and I know the volume, 28.50 milliliters of hydrogen gas, and I certainly know the gas constant, R, PV is nRT, I should be able to figure out how many moles of hydrogen gas I'm basically